attendees are in listen-only mode.
Welcome everyone to our second quarter webinar with Jon Hagar with Grand Software Testing. My name is Phil Liu with Exposoft, and today's topic is the top IoT testing challenges. And we're lucky enough to have Jon here. Just a little bit about Exposoft. We were founded in 2006, over 10 years ago, and we specialize in software testing and software QA consulting. We've got a global team with engineers located in San Francisco and in Beijing. And before we get started, here's a few house rules. All the participants are muted except for Jon. And you can ask questions through the GoToWebinar control panel. We will answer them throughout the presentation if we can get to them. And if they're not answered, we can try to answer them at the end. You will receive a recording, email with the recording, as well as the SlideShare slides. And that's about it for housekeeping. My name is Phil Liu, as I said in the beginning, and I'm the CEO and founder of Exposoft. But really, today is about Jon. So we're really lucky to have Jon here. And I was talking to Jon earlier about introducing himself. He says, well, I've been in the software engineering field for 40 years. So I just relabeled that as beginning of time. Welcome, Jon.
Thanks.
Jon is also an embedded testing expert, and he's also the author of a pretty well-known book on software test attacks to break mobile and embedded devices. And we've done webinars with Jon before, several. And I've worked with Jon on a few projects and see Jon on the speaking circuit quite a bit. So it's great to have Jon here. So let's move on. So Jon, I'll just let you take it away now. And I've given you control of the keyboard and mouse, and I'll let you do your thing. And I'll ask questions along the way and represent the audience.
Sure. And hopefully I am in control. I won't push the forward button just yet, but it looks like it's going to work there.
I think so. You're always in control. You're in control.
Yeah, that's a debatable subject, always. The Internet of Things, in my mind, is part of what's called the Industrial Revolution 4.0. And it's certainly been getting a lot of press in the last few years. And I've been looking at it coming out of the embedded space and the mobile space, where I did a lot of work for a lot of years. As the Internet of Things became possible, it seemed a natural movement for me. And I'll define what I believe the Internet of Things is. It's still an evolutionary area, but I was telling Phil, in my efforts to learn it kind of on my own, I've been programming some little Internet of Things robots, and I had it working about a year ago, or at least kind of working, and brought it back up after 4 months of hiatus because of the snow season. And surprise, surprise, something had changed. My connections between my PC and a little robot, it's a Raspberry Pi system, wasn't working. So it's taken me a day or so to kind of get it back again. And I've got a friend, Jane, I won't use her last name, and about a year or so ago, I talked with her on problems I was seeing in the Internet of Things. And she was working on a little Internet of Things controllable car, sort of like, instead of the slot racers of old, these were little cars that you can control with your phone. And we decided that the experiences she was having and I was having was pretty common. And so some of these challenges that I'm going to present here, I'm preferring almost now to call them opportunities for the people that are listening in now or on the future broadcast of this. But the Internet of Things, the devices out there can kill. We'll look at some of those that can kill. You see wild headlines of $4 to $10 trillion being spent over the next 10 years. Now, I have no idea if those numbers are real, but if they are even close to being real, there's an awful lot of, I'll call it, opportunity here on things. And my slide just advanced. Did you do that, Phil, or did I? So at any rate, lots of challenges, and I have to be careful with the control. So the few that I want to talk about today are on the specialized hardware, a little bit on the user interface challenges of things. There's a big area of third-party software, and I'll add in there hardware functionality and how we might test that. I'm also going to talk briefly about security and privacy, which a lot of us feel are the top one. You'll notice the little box over there on the side. I want to emphasize, I've been doing this presentation and variations of it for about a year now. This is probably the 4th or 5th variation of this. I don't always talk the same challenges and opportunities, but some of them I do come back and hit again. And security and privacy is a big one. So in that little box over there, you don't need to read all that stuff. It's out of a white paper that I've been working on for another place. Is another list of the challenges, and this is probably a quarter of the ones that I've come up with. So I don't want to say that these are our only challenges and opportunities, but they're the ones that I'm going to kind of talk about today. So in the technology space of things, we started out as humans with tools, and you can kind of see the physical systems of stone tools and things like that. Those go back tens of thousands, maybe hundreds of thousands of years, and they were around for a long time, certainly. And they're certainly physical systems. And let's see. Phil, did you just take control? Oh, there we go.
No, you're all in control, John.
So slow refresh rate. And starting, maybe 100 years ago or so, we started developing factories and other physical systems. Certainly our cities have been around for 5,000 years or so, but they've now grown quite large. And these are all physical kinds of systems. And humans have figured out how to work with those over long periods of time. Starting back in the 1950s, we saw the first computers, and actually during World War II, but that was kind of classified. But the real cyber system started in the 50s. Phil alluded that I've been in software for about 40 years. I was trying to think, it was 1977 or 78 that I wrote my first computer programs. I can't exactly remember. I'm getting that old. But somewhere in that time frame, I also bought my first PC in about 1979, and I was kind of the hot college student at that point, having that kind of system. And cyber systems have grown quite common. Certainly those of us that worked in the space, I never imagined that basically half of humanity would be walking around with a smartphone connected to the network. And I look at smartphones as really computers. I rode up a ski lift not too long ago with some 5- and 6-year-old kids in a gondola, and they all had their smartphones out and they're using them away. And I said, would you guys use computers? They said, oh, no, we don't use computers. We just use the phone. They kind of missed that the phone, the cyber systems are now in our pockets. And that really we're seeing a movement towards the cyber physical system. And IoT is really part of that. That's the one I'm going to kind of focus on today. But you're going to hear a couple times where I'm going to say, gee, these IoT systems really end up being part of larger systems and even systems of systems. And the number of devices and the amount of data that these things are going to be generating are just kind of astronomical, I think. And hopefully it'll move forward. Give Give it a second on the refresh rate.
So John, why don't you can you explain to me I know this is your symbol, I guess you could say, on the upper left, the guy that's hammering. It looks like he's holding a big baseball bat with.
It's actually one of those things I think the Vikings used with the spikes on it.
Oh.
Yeah, he's holding kind of a bat, if you will, and mashing the bug, and that's kind of. You used the word logo. I just kind of view it as the kind of thing that I like to do is find bugs. A lot more to testing than just finding bugs, but
well, that's why your book has the word attack in it, right?
Yeah, and it's not advancing on me, Phil. I'm not sure what's going on.
Okay, let me see.
Oh, there it goes. I just got it back.
Okay.
I couldn't see the little arrows on there.
All right.
So, yeah, and the word attack causes some problems with people because they think of it strictly as in the sense of hacking and security attacks. James Whitaker started using the word attack in some of his books. I like the concept of attacks as patterns. I'll talk about that in a bit for being part of exploratory testing. So there's a lot of test patterns that are out there. Most testers are well familiar with the concept of requirements, verification, checking. In fact, a lot of testers that I run into, that's the only kind of testing. They just want to get the requirements and show they're implemented. There's a lot more to it in my book. I've worked with risk-based testing most of my career. I think that's a big part of it. I've also been a bit advocate of exploratory and/or ad hoc testing, but I advocate that there's more that we're going to need in the space of IoT. So the first challenge opportunity that I've got is specialized hardware. And sure, a lot of the IT people and PC people go, well, we run on hardware. We've got hardware issues. But if you think about a smartphone, there's all these sensors in there. That started changing the world in the mobile space. IoT is going to take it to the next level. We're going to have sensors. We're going to have sensor packages. We're going to have controllers where we're controlling something, whether it's a car or a motor. And then we're going to have the communications, usually out maybe to a router or a smartphone, out to the web. So IoT, with this specialized hardware, you get all the problems of the PC and IT world, you get all the problems of the mobile world, and then you get these specialized kind of hardware issues that I think a lot of testers coming out of some of these other worlds are going to be surprised by. One of the solutions that I'd like people to start thinking about that gets a certain amount of consternation going is the notion of modeling. The world I came out of, the embedded space, some of the space systems I worked on, modeling was very common. I go to other places and the notion of modeling extremely unknown to many testers and organizations. And so I show a little diagram here out of UML, which stands for Unified Modeling Language. It's one of the standards organizations out there. And that whole little set of things that you see, SysML, SOA ML, and I've recently seen one for IoT ML. Those are all modeling concepts, systems, and languages, really, that may be necessary for testers to start learning something about in the IoT space. It's not that hard, it's not that scary, it is learnable, but it's going to be a challenge for people. There is something out there called UTP, that stands for Unified Modeling Language Testing Profile. It's a standard now, and it can be used to drive testing and test automation. If you're not aware of the UTP, and it's up to 2.0, it should be out in the next few months, and 1.2 has been around for about a year or two. that's something you should probably start going to look at. On the hardware side, I believe there'll be an interface between the UML side, the SysML side, and the CAD/CAM world, and that's computer-aided manufacturing design is what CAD/CAM stands for, which the hardware people have had for years. So as we merge cyber systems and physical systems together, a lot of you are going to have to learn that kind of concept, I believe. Now, model-based testing came out of the high-risk world. I've seen it used in medical devices, space systems where I grew up at. It's been in a minority of users, but it's growing in use. I go to Europe a fair amount. The Europeans are very much interested in model-based, both development and model-based testing. Also, Japan seems to be pretty big. And we can use model-based stuff to generate test cases, help in early validation, do things like simulation and the verification kinds of requirements checks, and even provide oracles. And you'll notice the supermodel there. Why is she there? Well, if you look carefully on her belt is a little device. I've got it blown up there. She is a diabetic. She actually has an insulin monitoring device and pump that she wears all the time. And true story here, guy that's been helping me, he's a diabetic. He's got one of these things. It's hooked to his smartphone. It gives him alerts and warnings. So it's an IoT device, and it goes the next step further. If he gets in trouble, it'll actually start notifying his doctor, things like that. That's pretty scary stuff if you think about it on things. And those devices are in use now. They're growing. The other side of that issue is what I term device management. As we think about these Internet of Things devices, we're going to have to address configuration management and control. Now, how does that affect testers? Well, what versions of software do you test on? The latest and greatest? Now, here's the problem there. My wife doesn't like the idea of updating her software on her systems all the time. We're going to have systems where these IoT devices, maybe the users don't want them updated. Do we have to test that? Don't know. It brings up the issues of recalls and updates. And also, do we push these systems automatically, or does the user pull them? If we push them, and the person is driving the IoT car down the road and it crashes because we're updating the software in real time where they're driving, that gets kind of sticky, one thinks. This brings up ownership and product evolution. We don't have the answers here, but as testers, we're going to have to start thinking about how that's going to work, how we're going to test that. And there at the very bottom, you see device management and analytics. I'm going to have some more works about analytics here in a moment, and because I've got some, I'll call it stern words there for people. So Phil mentioned that I'm a big believer in combinatorial testing. That's kind of the next challenge. One of the things I get at conferences and meetings coming out of the mobile space is people go, how do I deal with Android fragmentation? And that's the picture that you're looking at here, is the Android fragmentation map. And what we see a lot of organizations do is they just kind of test one area. They don't test everything because it's too many tests. Well, that's a challenge, certainly. Well, IoT is going to get worse than that, because you're going to have all the problems that we get with smartphones and things like Android fragmentation and Apple and all those kinds of things. We're going to be controlling our IoT devices many times through these kinds of interfaces on our smartphone or some kind of other little device like you saw on the model there. How do I test all those? Each one's going to have a slightly different user interface. And messing with my robot that I referred to earlier, another one of my robots, I have both an Android configuration and an Apple configuration. The user interface on those two devices for the single robot, the single IoT robot, is ever so slightly different. Do we have to test both of them? My answer is going to be yes, but how do we do that efficiently? Gets worse. You'll notice comm channels, how many communication channels are out there. Just to name a few, you got Bluetooth, you got Wi-Fi, you got near field communications, and the list goes on. You have various protocols. Now, Apple will tell you just buy nothing but Apple devices. Well, most of us end up having a mix of devices. What protocols do we have to test, and all of that becomes an issue. And then on the user interface side, you have the various kinds of stakeholder data. And I view what the user interface is just a form of getting data in and out of the computer. But you also have other kinds of stakeholders. Most of us immediately think, when we think of user interface, of the human user, but IoT devices are going to have all these other kinds of users and interfaces for them. I mentioned sensors and controllers earlier. Those, to me, in my thinking out of the embedded space, those are other users of my software. I'm going to have to test those. When you start adding all those things up, and this is just a little example of things, you can end up with something like you need to do 65,000 tests. Most testers will not want to run 65,000 tests. And that's where the notion of combinatorial testing comes in. This is out of a tool that's an open source free tool provided by National Institute of Standards and Technology called ACTS. It's a pretty nice tool for something that's free, and it's supported by US government tax dollars. So I kind of like it because I'm getting some of my tax money back. And this is just a little example where I took that 65,000 tests, I broke it into some parameters and variables, which you see listed there. And it produced a test case that you see at the very bottom of the page, where you see test cases and the platform and the kinds of configuration information. And when you do that, when you run that, you get down to basically like 120 tests. Now, you're not testing every possibility there that's important to notice, but you are testing a good representative sampling out of that 65,000. Most testers could figure out a way to do 120 tests. 65,000, probably not. That's kind of the power of combinatorial testing that I think will have to be brought to bear for IoT. Oop, kind of got ahead there. Let's see if I can back up. Now it's going the wrong way. It's not backing up for me, Phil.
You must be pressing the wrong button here.
No, I've got it backing up now. Hang on.
Okay.
I was hitting the wrong place on the screen. So the next opportunity, third-party hardware and software. What we see in most of these IoT devices is you don't build all the hardware and all the software from scratch. You go off and you buy components of hardware off the shelf. You buy an off-the-shelf processor, you buy an off-the-shelf operating system. Same thing for other elements of the software. They may come with some of these third-party elements. And my experience in dealing with third-party vendors and things like that is it takes a lot of work, and you have to consider it in testing. Another true story, years ago I was testing an embedded system in those days, and we would get these devices in, we would load our software in, we would run tests on it. And we got one of these devices in, we loaded our software, and things started failing. And we were like, what did we change on our software? And the answer was, well, gee, we really didn't change anything. We went to the hardware vendor and went, what did you guys change? Because the part numbers didn't rotate and update. And they said, oh, we didn't change anything. Took us about a month to realize what the hardware vendor had done, this third party, is they'd updated one of the transistor sets in their device. They should have rolled their part numbers, by the way, but they didn't because they said, well, the transistors were functionally equivalent. They weren't. It cost us about a month, maybe a little bit more of hunting ghosts from this third-party vendor, and this was not the kind of thing that management was happy with. So the bottom thing there, it's tempting to trust but verify. We learned on that one we had to verify these hardware things, and we've seen similar things on the software side. And the piece parts are liable to change, particularly during development and operations. Organizations I've been involved in, they keep having slightly new versions of the software and slightly new versions of the hardware. There's a lot of these providers, and you have to start thinking about testing of these things and regression testing to some extent. If you don't, you're going to get surprised by these types of activities. So little example here. Most of us paying attention to the news on self-driving cars. It's all the big rage. The US government last fall came out with a policy on this. I actually submitted comments on it. Haven't heard anything back on it with the changing of administrations. We'll have to see. But there's going to be some kind of policy, maybe some kind of standards on these cars. And these are really systems, and as I said earlier, I start looking at Internet of Things as being systems and systems of systems. If you look at the little picture there kind of closely, you'll see that's a car. If you look really, really closely, you'll see the car is covered in drapes. I live in Colorado in the mountains. Phil didn't mention that. We actually have a test facility. I've since found out who the car manufacturer is that has a test facility here. They bring their cars before they've been announced to the public and the automotive magazines here to Colorado to test them. And they cover them drapes, so you can't quite see all the details of the car. The reason for bringing them here to Colorado is we have things like bad weather, we have bad roads, we have high altitudes, we have snow much of the year. They've learned that they have to test the system of all these now Internet of Things, and many of the devices in our cars these days are really Internet of Things devices. They've learned they have to test them, and they test them in the field here in Colorado. And the government's going to have policies on that. There's a SAE, 5 levels autonomous, that's been defined. We're going to have requirements. I keep hearing from the policy that, well, they're going to be every bit as good as aircraft. But if you think about it, the world of aircraft, they still have pilots. They've always had pilots. There's a lot fewer aircraft in the air than there are cars on the road. And if you think about the number of cars and then the number of pieces in the cars, it's going to make it a much harder problem, I think, in this third-party space than airplanes. So I mention these things because this brings us to standards. Now, testers, a lot of testers that I know absolutely hate the idea of standards. Phil mentioned that I've been on standards committees now for a number of years. I do this somewhat out of preservation. I don't necessarily like everything in all the standards. I have a love-hate relationship, but I list some of the standards that are out there in ISO, and ISO is International Standards Organization, so I'm not going to read all those numbers, but there's a lot of standards, and the 26262 standard actually deals with cars. And as testers, we're going to end up in this IoT space, some of us, for these very critical kinds of systems. I believe we're going to have to deal with standards. Now, product standards are certainly going to be there. The difference between a process standard and a product standard is product standards addresses things like the communication interfaces, low power versus high power interfaces, network interface standards, processor standards. Those things certainly have a place and will continue to evolve, but there's huge numbers of them. The process standards more deal with how do we develop the system? How do we develop the software? How do we test the software? So there's certainly going to be a love-hate relationship there, but I mention these things because as testers, I think some of us need to be aware of them. The big one that I've been involved with for 20 years now is IEEE 1012. That's the verification and validation V&V planning standard. It's been around and in use, like I say, for over 20 years. I've used it. It is in process of moving from an IEEE standard to a world standard, an ISO standard. That's going to happen in the next 2 to 3 years, I'm pretty sure. And you kind of have to be aware of these things. I know a lot of people absolutely hate ISO 29119. That's the software test standard. Came out about 3 years ago. I was the project editor on it. Again, I was involved largely to try and make it as tolerable as possible. It has 5 parts. There's basic concepts and vocabulary. There's a process, part 2 standard. There's part 3 that addresses documentation, which is in the process of, I'll call it replacing the IEEE 829. There's a set of techniques in part 4, and then part 5 is keyword. The reason I mention it here is I've seen some other presentations recently on standards in the IoT space, and they referenced, in particular, IEEE 829. I don't think that they're aware that in the next year or two, 829 is going to be what they call sunsetted by IEEE, meaning they're no longer going to support it and no longer going to sell it. So these kind of standards are slowly going to, I'll call it, take over parts of the industry.
John, what part of the ISO 29119 standard would most apply to IoT that people really should pay attention to?
I guess I would say for me, the techniques would be the one I'd go to first, because it's a pretty good listing of all the techniques, software testing techniques. The process section would be good for organizations that are dealing with very critical IoT devices. I'm thinking medical and the automotive industry, those kinds of IoT devices, because the process standard is pretty heavyweight. Now, I always tell people when I talk the 29119, it was designed to be tailored. It was designed to be, I'll call it, evolved for particular situations. Unfortunately, a lot of people are lazy and they just want to use it out of the box as is. And then they look at part 2 and it's just too massive for anybody except maybe, like I said, space projects, aerospace, maybe the car industry, maybe the medical industry. So I would probably go with that one. The documentation one could be useful too, I guess. So kind of a sub-challenge here. The third-party people that I just talked about with standards, one of the things that I started seeing is IoT is going to bury us in data. Most of these companies have the comm channel. They want to collect usage information and data information coming off these devices. It's going to kind of be the standard in the DevOps testing world is getting all this data. Now, the people that I've found that are most interested in the data on these things are the marketers, the people who are going to be selling these things. And they're talking huge amounts of data. You'll see here in a moment, I'm advocating that a lot of you as testers need to start looking at this data too, because it isn't just the marketing and sales. Certainly that'll be the starting point, but we will be able to access a lot of data that's of interest to testers. Now, the attacks that were talked about earlier that I wrote my book on were actually developed from data coming off of embedded devices and then the mobile space into what's known as a taxonomy of patterns. So I've been doing this kind of patterning of data for years in first the embedded space and then the mobile space. And I think an awful lot of people in the testing world don't use the test data that they have after the testing is done. They don't look at their error logs. They don't look at those kinds of things. And so they miss a big opportunity for improving their testing from that. And the stuff that I've started being interested in and not knowing near enough about is the notion of what I call self-organizing data analytics. You see this already in AI, things like Watson, deep learning, neural nets, and statistical analysis, which, again, I realize an awful lot of testers are afraid of those kinds of things. They will shy away from them. But when you're talking exabytes worth of data coming in on a real regular basis, you can't do what I did, which was analyze individual data points. You're going to have to figure out ways to use tools. Now, I started talking about this last year at numerous events, and some of my presentations were kind of rated down because the testers said, gee, we don't see this as being practical to us. I would like to encourage people in the testing space, don't say that you don't care about the data. That to me is a big mistake. And saying that, gee, I don't want to learn how to use statistical analysis or use AI tools or neural networks to figure out how to analyze the data coming in off of DevOps, I think will be a big mistake. And the companies that figure out how to do it and the organizations that figure out how to do it, I think they're going to be really successful.
Yeah, just as a small addition here, I'm almost thinking now that the testing of data will get to be a specialty for software testers.
Yeah, I would think so, because how do you know that your data coming off of the data analytics is right?
Right.
You know, and telling you what you really want. Yeah, there'll certainly be an aspect of this space for that. So we've still been dealing with the third-party stuff, even though we kind of branched off into the data analytics side. And so the things that I always did in third-party is I would evaluate my risks. We started evaluating the vendors as soon as we started basically the development process. Now this moves a lot of the tester activities to the left, but I did this in the embedded space. I was part of the team that evaluated the hardware, part of the team that evaluated the software. We used the data coming off of our testing to decide, gee, we're going to select this vendor over that vendor. Because sometimes it isn't the cheapest vendor that you want to select. Sometimes a better vendor is a little more expensive, but gets you a product that you can really use. So testing in the third-party world starts early. Expect regression testing. I see no way to avoid it. And it will be a challenge to figure out how to do it quickly and maybe even use the, I'll call it customers to help with the testing a little bit. We certainly see that in the DevOps world. And we're still going to have to check the requirements and do the exploration, certainly.
You know, John, for all of these issues in IoT testing, is there a place for test automation and performance, or do you think it would be mostly manual testing? It just seems like there's so many different permutations to test. How can it all get done?
Right, sure. And in an hour, I can't cover that. Back when I was talking about the model-based testing, the real purpose ultimately of the model-based testing is you would use the models to generate test scripts that would then be executable directly. So the model-based testing systems that are out there that I'm familiar with can generate huge numbers of tests automatically, and then you feed them into a text execution system and run them. Now that introduces the problem of the test oracle. How do you know when you're running lots and lots of tests that the tests are working and when there's a failure? The model-based stuff offers some hope for that. The combinatorial people have some interesting variations, but it's a little bit out of the scope of this session. But you're right. I think ultimately with the third-party stuff I just talked about and that model-based stuff, I think there'll be a lot of automation necessary in the IoT space. There's also good room for good exploratory manual testing too, though.
Mm-hmm.
So the other one that I talk about quite frequently, it kind of wakes me up sometimes at night, and we joke, I live in a bunker. Phil gets that joke, the rest of you don't, is Internet of Things security and privacy. It's a big issue out there. And so I always talk this session just because to me, it's a little scary with all that data floating around. I just saw there's a new movie called The Circle with Tom Hanks that's dealing with some of this stuff. I don't know much about it yet. I guess I'll have to go see that when it comes out. But it gets us a little bit into the notion that some Internet of Things players, and I'm thinking some of the smartwatches that I've had and things like that, appeared to me I was kind of being one of their testers. And there are an awful lot of programming errors that the developers should have found, but some places I've supported, the developers were like, well, we don't have time to do testing, so that's the tester's job. Terrible viewpoint of things, because that's the vulnerabilities the bad guys go after. Also, hardware can now be a vulnerability. The system environment can be a vulnerability. And the unusual stress cases can be all out there. And we saw in the Internet of Things space last year the first use of IoT devices for the denial of service attack. It kind of set a precedent and happened just about the time I was in Europe talking at some conferences, and the other security people that know much more about security development and testing than I do were, all shaking their heads. And I asked them questions and they go, we don't have answers. You're asking the right questions. You go figure it out. Which, by the way, doesn't make me feel any better, because I'm like, somebody should have answers for these things.
So John, just as a personal side note, so can you go back one slide? If you look at all those those devices there, I'm wondering which devices you have, and what kinds of extra precautions do you take? Do you have an Apple Watch or a smartwatch of any kind? And other devices?
I do have an Apple Watch. I do have both Android and Apple smartphones, and I do take some precautions. Of course, I run antivirus stuff all the time.
Yeah.
Phil this morning caught me backing my systems up. I back my systems up on a real regular basis because I figure it's just a matter of time before something gets hacked with, where they lock up my system. And my attitude is I'm just going to, flush everything out and reload things. So those are the kinds of things I do. And yes, I also live in a place where I can go off grid if I need to.
Okay.
You've seen my house, Phil.
I know.
Yeah. So the notion of exploratory testing with attacks now come in, and want to wrap this up pretty quickly. But for me, an attack is a pattern based upon a common mode of failure, that the attack targets that common mode of failure. And this brings in the notion of the data analytics side that I think people have to start doing, because I built for years a taxonomy and a series of taxonomies that then expose certain kinds of patterns for testing that could be used over and over in a generic sense. And that's what I wrote my book on that Phil referred to earlier. Lee Copeland, in his book on test design techniques, talks about building taxonomies. And so I've been talking error taxonomies probably for close to 10 years now. I find very few testers that build their own taxonomies. It's one of those areas, sort of like the data analytics, that testers just seem not to be that interested in doing. But projects I worked on, one of the first things I did, if it was an existing project, is I analyzed their error database, their error logs, for useful information. And then when I kind of went off on my own, I continued that. And what I've decided is testers all learn these patterns themselves. Once they get experienced as testers, they have mental patterns. They know if they do certain things certain ways, they will find errors. Patterns attacks try and encapsulate that into something that's a little more formal and usable. In my book, there's the software test attacks to break mobile embedded devices. I had a chapter or two on security attacks. They were only the tip of a very large iceberg, the 10 or so that you see there. They're also getting dated. I would like to see more of these kind of attacks, particularly in the Internet of Things space. But it's at least a start on that kind of stuff. And what I've found is that now there's a lot of interest and good career for a lot of people actually on doing crowdsourced security hacking, attacks from the outside. There's several people that I know around the world. And they kind of do it almost on the side, at least a couple of them, but they get hired in to try and break into mostly IT systems and PC systems. I think some of them started doing a little in the mobile space, but it's a crowdsourced security hacking. That's a good thing to do. But I think some organizations I've run into are doing that as opposed to doing good internal testing, looking at maybe some of the other kinds of patterns that are out there, like developer testing and combinatorial testing, because I think first line of defense is being a good line of offense inside of your company. And then I'm back to that data analytics and scientific exploration. I think that's a best thing. If you combine those things, you might be pretty good at hacking for improving the security of your system. You're never going to be 100%. So I mentioned these other kinds of attacks. This is a list of them at a summary level out of the book. I'm not going to read all that stuff, but the book is still available. I'm also working on some Internet of Things books that are currently up on LeanPub. There's 3 versions. I'm taking a very agile approach. So the books aren't 100% done yet, but I'm putting the books out there, hoping people will send me comments. I've only got 1 set of comments in a year now, but the books will be on LeanPubs. They'll continue to evolve. At some point, I'll charge for them a little bit. But right at the moment, the 3 books that are out there are kind of free. Can't beat free, right? People like free. So in summary, for me, you got to kind of know the enemy to find them, and I'm referring to bugs. But I can also refer to other kinds of information that testers should provide, things like reliability, which will be big for Internet of Things. I mentioned the security and privacy. That's other kinds of information. There's a whole list of information that are kind of things that testers are going to provide. The Internet of Things is new enough. There's not a lot of data on it. I go to conferences. I ask other people working in the space, stories, share your data. It's hard to get data out of companies. The taxonomy that I produced was all produced out of public domain data. Why? Because most of the companies I've worked with got very nervous when you started kind of airing their dirty laundry. But as testers, if you're inside the company, you can use that data. I mentioned that concept of patterns. I mentioned the IoT test book, which is out on LeanPub, free. I'm going to be in another month, end of this month, at the Mobile and IoT conference, where I'm going to present another variation of the same challenges. There are going to be some different challenges and different information, so it's going to look different than this set and the sets I did last year, but I'm talking on this continuing subject there. And then I really think the book that I did still has applicability for those things. I think in many ways, the software is going to be one of the big limiting factors. You hear this out of a lot of companies these days that say, gee, we're moving from being an auto manufacturer to being a software company. That's why you see a lot of companies that have manufacturing hardware capabilities teaming up with software companies. A lot of big names come to mind there. They're all realizing that they're going to be putting software in everything, and that's going to be a big factor in success and failure. And I think testing is a big part of doing a good job on software on this stuff. And I will say I do some exercises where I pose to people, gee, how would this thing become an Internet of Thing? And I do it with some interesting ones. I'll leave you with that parting thought. How would a diaper be an Internet of Things? I have an answer for those that want to email me. I like to provide references. So the last couple charts here in the thing is I get a lot of good ideas from other people at conferences, a lot of other books, and I like to give credit to all these people. It's hard to put references and charts and things like that, but I think a lot of credit goes to people like Dr. James Whitaker, Kem Kainer, James Bach, and a lot of other people that I hope they're still my friends on things. And
I'm not. What happened to me? I'm not on there.
You didn't write a book, dude.
Oh, okay. Shoot.
Those are all books. But I do get good ideas from Phil, and it said a lot of other people.
Yeah.
We all learn from each other in this business, and these are some of my favorite references and sources I go to for learning more about testing. While I've been in the industry for 40 years, I'm still learning.
Yeah. This is
any questions, Phil?
This is great information. If you can go back to the summary slide, I just wanted to look at that one more time. No, go backwards. Okay.
Now you went too far.
Yeah, what I was going to say was I think I was reading the other day that every business is now a software business. And, you have that kind of in the bottom bullet point here. And I think that's really important that with IoT, a lot of typical hardware companies are now moving into software. So they either have to hire a software partner or they have to become immediate experts in developing software. And that represents a lot of opportunities and challenges for software quality and software testers.
Yep. It's easier said than done.
Right. As you know, we work together on a company that made speakers, right? And they were moving into the software business, and we work now with a company that makes traffic camera and control systems. So it's no longer a camera company. It's a real software company. So it's really interesting how software is really penetrating everything. And I think the big takeaway for me is if that second one there is about the data, and it's really centered around data in terms of testing the data and making sure it's correct, but also that's what people want. So that's also the security side of it.
Yeah.
It's all
I found it really surprising last year on some of the feedback, because I was talking test data and data analytics and things like that.
Right.
And a lot of testers seem to kind of reject it because it wasn't in their comfort zone.
Right.
And
right.
I think that's a real danger for their careers.
Sure.
Because in the long term, this stuff, somebody's going to figure these things out. Some
Sure.
testers figure these things out.
Yeah.
Might as well be people listening to me.
That's right. Yeah, it's really no longer just ETL, extract, transform, and load, especially when you're talking about all these different systems connected to each other, and gets to be pretty complex. So I think that's where also the combinatorial testing could really help out if we as testers really became good at really understanding how to reduce the number of combinations that need to be tested. That would definitely be a help for sure.
Yep. And testers have to get away from the idea that everything is just checking the requirements.
Right.
Which is being a mathematician. Once upon a time, we talked when you were proving things, there were what they call necessary but not sufficient conditions.
Right.
So they were things you had to show, That was the necessary part, but
Yeah.
they, by themselves, they weren't sufficient. And
Yeah.
just checking the requirements, and that's not sufficient.
Right.
Particularly these
Yeah,
big systems.
I mentioned on a webinar last week that I was on that, the days of software testing where you check to see if a button works and if it provides the expected results, those days are over. That's almost like being a factory worker that puts on hubcaps, right? So we certainly have to move much farther beyond that.
Yeah, and again, Dr. James Whitaker upset people a couple years ago when he said testing is dead. What he was really talking about is that pushing the button.
Right.
Test.
Right. So, well, thanks a lot, John. We really appreciate all the information and knowledge that you shared with us and our audience today. Just in closing, you can find ExpoSoft all over the internet on Facebook, Google Plus, and LinkedIn, and we will be posting some questions that came in that we're not able to get answered today. We'll be posting those on our blog, and feel free to download any of our white papers. We have a lot of white papers on this kind of thing and mobile testing and so forth, and we'll be sending a follow-up email with the recording as well. So thanks very much, everyone, and we'll see you in the next quarter for our next webinar. Thank you. Thanks, John.
Yep.